Hello, today I'm going to show you how to use a decision making technique in a very complex decision making situation. It is called Analytic Hierarchy Process, AHP, and I'm going to demonstrate how to use Analytic Hierarchy Process, AHP, using an example. Uh, you know, very often one would face a situation where there is a complex complexity of problem is in there, and then you need to kind of make a decision, and you are kind of going around and around because of the complexity of the problem, and you couldn't clearly decide because you are lost with what is the priority, which one is the priority, or so on. So this is a mathematical and psychological approach how you can kind of really prioritize and put it in hierarchy so that you can quantify the values, and instead of thinking the problem as a whole complex with a lot of parameters or criteria, you can kind of break down into two pairs uh, and compare between each of these and quantify those. So at the end, you can easily rank them so that you can see that okay, this is the priority. So in this example, I want to buy a phone which will give me the most value for my money. It should be economical, but at the same time, I have certain parameters or criteria which I feel that important. So let me demonstrate how it is. So I have these phones here listed like Moto X Style, G4, Samsung S5, and i7. So, and this is my disclaimer. These values are just examples, so don't take it take it as like really literally. Anyway, I want to choose between these phones, and I applied the AHP process, and I put that in an Excel sheet and worked out with the numbers, and finally what I get out of was this graph. So I got this kind of scores finally: 88 score, 81, 63, and 99.7. These are weighted scores for each of these parameters I chose, and I plotted that in a graph. As you can see, in the y-axis, I plotted the benefits, which is these score values, and in the x-axis, I plotted the relative cost, not the actual cost, but the relative cost. Relative cost in the sense that, okay, for example, Moto G4 Plus is a €200 phone. So compared to that, I took this lowest value, and then I kind of compared how much is the relative cost of the other phones in this case. So I got these values 2, 1, 1.7, and 3.5. As you can see, I have put in the x-axis this relative cost, and I came up with these values. From this, I can easily see that this one, this 81, 81.665 is the weighted benefit I get for cost, one relative cost. And the next one is this one. I get 88 for 2. And this is also close. So as you can see, these are like really close, 1 and 2. With the, if you see from the y-axis, the benefits are almost close, 81 versus 81.6 versus 88.6. But the cost I would pay, it will be double. So in this case, Moto G4 Plus 81%, 81 weight, and Moto X Style is 88. So I would have to pay double cost, 400 versus 200. So So this is the best choice for me in this case. How I reached now to this conclusion, I'm going to explain this AHP here. So I put all these parameters or criteria which I thought are important in these rows. 6 parameters I chose, and I also put them in the column. So you just fill these these names, and then as you can see, we are going to compare each criteria against each other. So camera to camera, we can't compare those. So that's why these are all one highlighted in yellow. So you just put one here in this diagonal, and all you need to do is just to fill the upper right part of the matrix above this diagonal. So in this case, camera versus screen. So when you compare camera versus screen, this is the scale you are using basically, this highlighted area. So if you think that camera is the most important parameter than screen, then you put 9 because it is the most. But if you think that screen is the most compared to camera, then you can put 0.11. That is nothing but 1 by 9. 1 divided by 9. Like that, if you put all the values, I'm kind of having these scales. So it is like a odd scale, 1, 3, 5, 7, 9. And the right side of the scale is 1 by 3, 1 by 5, 1 by 7, and 1 by 9. And the middle, 1 is equal. So if you thought that camera and screens are equal, then you can put 1. So I am just explaining you. Camera, screen, 1 by 3. Camera, battery, because in this case battery is more important, so 1 by 5. Camera and software are equally important for me, so I put 1. But camera and support, I prefer better camera than support, so I put 5. So that's why I went to the left side of the scale instead of right side of the scale. When you think right side of the scale is important, then you can go the right side. If you think left side is important, then you can go left side. Like that, you can fill all these. But then the lower part, you don't need to worry. You just have to take the reciprocal of these values. For example, in these highlighted rows, you have 0.33, 0.20, 1, 5, and 0.20. This is nothing but 1 by 3, so you put 3 here. So similarly, 0.20 is nothing but 5, so that is 5. These are reciprocal values. These columns are reciprocal values of these rows. So once you fill those, you just add those values. So the sum is, in this case, 15.2, 7.87, and so on. So 15.20 is sum of this column, camera. So the total camera weight is this one. Now you have to distribute this weight. So for that you can create another table below with the standardized matrix. So what you do is you just take the first value and you divide by this. So 1 divided by 15.20 will give this. 3 divided by 15.20 give this, and so on. So these are highlighted values here. So thus you get these values. But when you add this value, you get this. Basically, you are dividing this value with these weights. So you get this. So similarly, you will do this for all these other parameters as well. Once you do this, then you can kind of get the average weight. So to get average, you can add all these 6 values and divide by 6. That gives you, as you can see, sum of M11 to R11 divided by 6, and then you multiply by 100, which give you the percentage. So what we see here in the weight percentage is 24%, 29%, 16%, and so on. And now we can rank accordingly. So first rank goes to battery because it's 29%, and then second rank goes to speed, third rank goes to software, and so on. So that's how we reached here. Now, as you can see, we take a model